find the modulus of 1 plus I by 1 minus I minus 1 minus I by 1 plus I. Pause the video, try this out. Alright, let's do this. To find the modulus of a complex number, we need its real part and its imaginary part. We have 1 plus I, 1 minus I, minus 1 minus I by 1 plus I. Taking the LCM, we'll have 1 minus I times 1 plus I in the denominator. And in the numerator, we have 1 plus I squared minus 1 minus I squared. So let's open the squares. We have 1 square plus I squared plus 2I minus 1 square plus I squared minus 2I. Now I squared is minus 1. So let's replace I squared by minus 1. Let's see what we have. We have 1 minus 1 plus 2I minus 1 minus 1 minus 2I. And the denominator is 1 minus minus 1, which makes it 1 plus 1. So 1 minus 1 is 0, 1 minus 1 is 0, 1 plus 1 is 2. We have 2I minus minus 2I, which means plus 2I. So 2I plus 2I in the numerator. And the denominator is 1 plus 1, that's just 2. So this is 4I by 2, which means it's 2I. So this expression is equal to 2I. Now we need to find the mod of 2I. That's just 2. Its real part is 0. That's 0 squared plus imaginary part 2. That's again 2 squared. So 0 squared plus 2 squared. That's 4. Root of 4 is 2. And we can also see that this complex number is 2 units away from the origin. Let's try another one. We have two complex numbers, Z1 and Z2. Z1 is 2 minus I, Z2 is 1 plus I, and we need to find the mod of Z1 plus Z2 plus 1 by Z1 minus Z2 plus 1. Pause the video, try this out. Okay, let's do this together. Let's plug in the values of Z1 and Z2 in this expression. The numerator will become 2 minus I plus 1 plus I plus 1, and the denominator will become 2 minus I minus 1 plus I plus 1. So in the numerator we have minus I and plus I, that cancels out. 2 plus 1 plus 1, that's going to be 4. And the denominator is 2 minus I minus 1 minus I plus 1. Here 1 and minus 1 cancel out. We have 2 minus I, so that's 2 minus 2I. So we can take 2 common, that's 1 minus I. And we can cancel this 2 with this 4. We'll have 2 divided by 1 minus I. So we need to take the mod of 2 by 1 minus I. We have work to do, but it's still better than this expression. Now let's rationalize the denominator. We have 1 minus I here, like we had here. So we'll multiply numerator and denominator by 1 plus I. So this becomes mod of 2 by 1 minus I times 1 plus I by 1 plus I. Numerator becomes 2 times 1 plus I. Denominator becomes a minus b into a plus b. That's a square minus b square. That's 1 square minus I squared. I squared is minus 1. This will be 1 minus minus 1. That's 2. And 2 will get cancelled out. So we'll have 2, 1 plus I by 2. That's just 1 plus I. So now we're looking for the mod of 1 plus I. That's equal to square root of 1 square plus 1 square. That's equal to root 2. Alright, let's try one more. Find the mod of x plus I square divided by 2x square plus 1. Pause the video, try this out. Okay, again for the mod we need the real part and the imaginary part. We have x plus I squared. Let's open the square. We have x square plus I square plus 2xi. The denominator is real, 2x square plus 1. So in this case, we don't have to rationalize the denominator. If we split the numerator into its real part and its imaginary part, we'll have x square minus 1. I square is minus 1. That's the real part. And 2xi is the other term. 2xi divided by 2x square plus 1. So the real part is x square minus 1 by 2x square plus 1. And the imaginary part is 2x divided by 2x square plus 1. So the mod will be square root of real part square plus imaginary part square. X square minus 1 by 2x square plus 1 squared plus 2x divided by 2x square plus 1 squared. Now we can simplify this. This denominator is 2x square plus 1. We first square it, take the LCM and then take the square root. So we can take it out entirely. We have 2x square plus 1 in the denominator. In the numerator we have square root of x square minus 1 squared plus 2x squared. Now let's open the square. We have x to the power 4 plus 1 minus 2x square. This is a minus b whole square plus 2x whole square. That's equal to 4x square. So this is x to the power 4 plus 1 minus 2x square plus 4x square. Minus 2 plus 4, that's plus 2. So this is x to the power 4 plus 1 plus 2x square. Now this becomes, within the square root, this becomes a square plus b square plus 2ab, which means it's x square plus 1 whole square. And we can cancel square with the root. We have x square plus 1 in the numerator and 2x square plus 1 in the denominator. So this is the mod of this expression. One last problem. Find the mod of z when z bar, the conjugate of z, that's given as square root of a minus ib by c minus id. Pause the video, try this out. Alright, let's first rationalize the right hand side. We have a minus ib by c minus id within the square root. So we can multiply and divide this by c plus id by c plus id. This is the conjugate of the denominator. This becomes, the numerator is a times c, that's ac. Let's look at the imaginary parts. Minus I times I, that's going to be minus I squared, that's going to be plus. So the sign is positive. And then we have b and d. So this is ac plus bd. And then the imaginary parts, minus ib times c, that's going to be minus bci. And then a times id, that's going to be adi. So we have these four terms in the numerator, ac plus bd, that's the real part. And then adi minus bci. What's in the denominator? We have c minus id times c plus id. So a plus b times a minus b, a square minus b square. This is c square minus I square d square. I square is minus 1, minus minus plus. This becomes c square plus d square. So the denominator is real and the numerator has real and imaginary parts. Now we're asked the modulus of z, but mod of z is same as mod of z bar. That's square root of x square plus y square if x is the real part and y is the imaginary part. So we'll just take the mod of z bar, what's given here, that's equal to square root of the real part squared plus imaginary part squared. This is ac plus bd by c square plus d square whole squared. That's the real part squared plus ad minus bc divided by c square plus d square whole squared. So this is your imaginary part squared. Now the denominator is c square plus d square squared, and then we take the square root. So square root and square cancel out. We have c square plus d square in the denominator. We can cancel these things out because we're dealing with only positive values. C square plus d square is positive. Alright, back to this. We have square root of ac plus bd whole square plus ad minus bc whole square. Now we can open the squares. We have a square c square plus b square d square plus 2abcd. And here we have a square d square plus b square c square minus 2abcd. So 2abcd minus 2abcd cancel out. We are left with these four terms. So this becomes square root of, if we take c square common, we have a square plus b square, plus if we take d square common, we have a square plus b square. So we can factorize. This becomes square root of c square plus d square times square root of a square plus b square. And the denominator is c square plus d square. So root c square plus d square and c square plus d square, we can cancel this out. This becomes root a square plus b square by root c square plus d square, or square root of a square plus b square by c square plus d square.